All right, so we've covered the operations of addition and subtraction, and now we're ready to move on to multiplication of matrices. And there's really two types. The first type is really pretty simple. We won't spend a lot of time on scalar multiplication. We'll spend the bulk of our time in multiplying two matrices together. And so let's cover this idea of scalar multiplication first. And I gave you an example in your notes. This word scalar, if you're wondering what in the world is that, it really just refers to a real number. In this case, our scalar factor is the number 4. So to me, a good way to relate scalar multiplication is to think of the distributive property, except with matrices. We're going to take this scalar factor and we're going to multiply it times each one of these elements individually. So there's really nothing to write on this first example. I went ahead and gave you the answer. 4 times each one of these blue elements gives us our red, what we would call the scalar product. Product means the result of multiplication. So that is scalar multiplication. Pretty simple. If you think about the distributive property in the old days, it's like that, using a certain number, a real number, times each individual element of a matrix. So let's practice probably just one of these. I don't think we're going to need to go through all of the examples I've given you. Your book, for some of the homework problems, they're going to provide you with, sometimes, I can't remember, maybe it's like 4 different matrices, and you have to pick the right ones to use. Here I just gave 2, and what we're told to do is do scalar multiplication 5 times the B matrix. Let's just go ahead and do that first. So if we multiply 5 times the B matrix, we get 15, 0, 30, negative 5, 40, and 10. Okay, and usually the question arises at this point, and it's a good question, can I multiply the A matrix by negative 4? What would you say to that question if someone were to ask? Is it okay to multiply the A matrix by negative 4? Would anybody say that it is okay? I would say it's okay. But what does that mean our operation is going to become? Yeah, so if you want to multiply by negative 4, that's fine, but then you need to change this into addition, because isn't adding a negative the same thing as subtraction? I'm going to choose to just go ahead and leave it subtraction, and I'm going to multiply by positive 4. Just want to make sure you're clear. If you did multiply by negative 4, then you need to change it to addition. So 4 times every individual element of this A matrix. 4 times 2 is 8, 12, negative 28, 4, 16, and 20. And now we're back to what we were doing in the previous lesson, just subtracting 2 matrices. We match up the elements and we subtract. So here is our answer matrix. 15 minus 8 is 7. 0 minus 12 is negative 12. 30 minus negative 28 is 58. Negative 5 minus 4 is negative 9. 40 minus 16 is 24. And 10 minus 20 is negative 10. And that would be my answer to this problem of finding 5b minus 4a. I think that's pretty straightforward. I wanted to do one of these because you've got, I think your first 4 or so homework problems look like this. But I don't think I'm going to do these other examples just to save time. So we'll skip over this example, 1b. We can skip this one because it's basically the same thing. Negative 3 times the M matrix, 7 times the N, and then you add those two results. I do want to do this one, however. This is Roman numeral 2, letter A. Another matrix equation. We've already been working a little bit with matrix equations, but this one's going to involve scalar multiplication. So my first move in solving for this matrix called Y, my first move is to find out what this scalar product is. 2 times this matrix. So I'm going to bring down minus 3Y, and 2 times this matrix becomes 12, 18, negative 24, 30, and I'm going to bring down the matrix on the right. Okay, and much like we did in the previous assignment, I'm trying to get Y by itself, so I'm going to need to subtract this matrix on the left from both sides of the equation. I'm not going to write that step. I'm not going to show it. I think we can just do some mental math. So remember, it's important that you start with the matrix on the right and subtract this matrix from it. That is important, that you get that order correct. 27 minus 12 is 15. Negative 18 minus 18 is negative 36. 30 minus negative 24 is 54. And 6 minus 30 is negative 24. Just like in the past, when this was a real number equation, to solve for Y, we undo multiplication with division. We would divide by negative 3, or you could multiply by negative 1/3. But in this case, we need to divide each element by negative 3. So 15 divided by negative 3, negative 5. Negative 36 divided by negative 3 is positive 12. We have negative 18. 18. And this is going to be positive 8. And that is the matrix Y that we were supposed to solve for in this equation. Any questions so far? No questions. Great. Okay. Well, I want to spend the rest of our time in a technique that's going to be involved when we want to multiply two matrices together. And I've given this in your notes, this star saying that I've got here on this notes that says first. This is extremely important because matrix multiplication is not always possible. And let me follow that statement up with this. Matrix multiplication is not commutative. Those of you Algebra 1 pros, what is the commutative property all about? Give me a brief description of what the commutative property means. No, it's not matching. The word commute, if you commute to work, means you're moving. Does that give you a hint? Moving. Well, let me give you an example of the commutative property, and then you put it into words. The left side of the equation, according to the commutative property, is the same as the right. Because with multiplication, I can change the order, or I can move the terms around, and I still get the same answer. That holds for multiplication. It also holds for what other operation? Addition. Does it hold for subtraction? No. 6 minus 4 is not the same thing as 4 minus 6. Does it hold for division? No. 4 divided by 6 is not the same thing as 6 divided by 4. Now that's true in the real number system. The commutative property holds for multiplication, but it's not true for matrices. The blue times the red is not the same thing if I switched them around and I did the red times the blue. They're not the same. So for that reason, I've got to leave the matrices that I'm given in this order, and now I'm ready to decide whether or not multiplication is even possible. So what I've done here is I wrote the dimensions of each matrix. The red matrix, obviously they're both the same, but just for purposes of illustration, the red matrix, I just wrote the dimensions here in red, blue matrix in blue. Now here's how I'm going to test to see if multiplication is even doable. As you can see here, I'm going to look at these numbers. After I write the dimensions down, I'm going to look at the numbers on the inside. If they don't match, then I cannot do multiplication. Those are great homework problems because if these numbers don't match, you're going to write not possible and you're going to move on. Okay? Or you can write undefined. It's fine. In this case, we know multiplication is possible because they do match, and there is significance to these numbers on the outside. When we know multiplication is possible, the outside numbers give us a clue as to what the product matrix should look like. When I'm finished, I should end up with a 2 by 2 matrix according to these outside numbers. So one more time. Check, first of all, to make sure multiplication is possible. Write the dimensions of each matrix down. Compare the inside numbers. If they match, you're good. The outside numbers then can guide you because they represent the dimensions of the product or the answer to multiplication. All right, so let's go on and let's go through the technique. We've established whether or not multiplication is possible. Now, here's how multiplication happens. When we state the dimensions of a matrix, remember how we do that? There's a certain way the dimensions have to be written. It's always row first, column second. Remember that? Row by column? Well, in that same way, multiplication happens like this. We multiply row of the left matrix times column of the right. It's always row times column. And I've intentionally color-coded some elements here just until we kind of get used to this so you can maybe hopefully make this a little bit easier. So I'm going to walk you through how to get the product matrix. I think it helps to understand what we're looking for in our answer. This is called location row 1, column 1. Would you agree with that? Since it's row 1, column 1 of my answer, then I'm going to use row 1 times column 1 in order to get the answer part, row 1, column 1. So here's how it works. Row 1, and just do some circling for just a minute, times column 1. So I'm going to take the first element from each, the first element of the row times the first element of the column. I went ahead and color-coded them to make it a little bit easier to follow. -3 times -1. You always add these products when you're coming up with the final product matrix. So I did -3 times -1. Now I'm going to do plus. Now I'm going to multiply the second number of the row times the second number of the column. Notice they're both blue. 3 times 3. So the number of my answer that is in row 1, column 1 is going to be 3 plus 9, which is 12. Okay, now I'm going to move over and I'm going to fill in the part of my answer that is row 1, column 2. Well, that's easy to remember if you think about it because I'm going to need row 1 from the left times, this time, column 2. So I'll do the blue rings. Since this is sitting in row 1, column 2, I use row 1 and column 2. And you just match them up. First of the row times first of the column. Red with red. -3 times 0. Plus, and now I'll do the second of the row times the second of the column. Blue with blue. Always add. So 0 plus negative 12 is negative 12. Now let's work on the bottom row. This location is called row 2, column 1. So think about it. You're going to use row 2 multiplied times column 1. First with first. Red with red. 5 times negative 1. Always add. And now to use the second of each. The second number of the row times the second number of the column. Blue with blue. Add those together. Negative 5 plus 0 is negative 5. And now we're ready to do row 2, column 2. So we use row 2 times column 2. First with first. Red with red. 5 times 0. And now slide over and do the second times the second. Blue with blue. Of course, that's 0. So this represents what we would call the product matrix, or the answer to multiplication. And that's the technique. So before we go on and practice some more, I'm just going to recap. It's always row times column. It's always first times first plus second times second, always plus. Okay, you're always adding when you come up with these products. And again, you can. I think it's a good idea to go ahead and make a blank matrix that will be these outside numbers to give you some guidance. Sometimes I run into people that they understand multiplying row times columns, but they end up with a matrix that's different dimensions than what these outside numbers indicate. So just pay attention to what these are and let that guide you toward your final answer. Okay, so let's practice. Here's our letter B. I'll get some help with this one. First of all, let's check and see if multiplication is even possible. I went ahead and wrote the dimensions of each matrix down. This left matrix is a 2 by 3. The right matrix is a 3 by 2. I noticed the inside numbers agree or they match, so we know multiplication can be done. And the outside numbers are 2 and 2, which indicate that's the dimensions of the product. So I just went ahead and wrote a blank 2 by 2 matrix. So I'll get a volunteer for this first time. Help me out with, and be specific, don't just give me a final number. Tell me how to go about getting row 1, column 1 of the product matrix. Okay, Dalton?
What you do is take 4 from the first matrix.
You mean the first matrix? And what do I do with those? Okay, 4 times 4. Okay, then what? Matrix. Okay. Okay. Now we add them up. 16 plus 24 is 40. 40 plus 20 is 60. Okay, somebody else want to help us with row 1, column 2? Any volunteers? Kennedy. Good. 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 Okay. Can we do some mental math? 28 plus 18. Plus 10. Good. Okay, let's work on row 2. Row 2, column 1. John, can you help us with that? To get row 2, column 1? let's see, row 2 times column 1. So match up first with first. I got them color-coded for you. Okay, 0 times 4 plus. Okay, so you're doing row times column. One times 8 plus. Okay, let's put it all together. 0 plus 8, 8 plus negative 70, it's negative 62. And Sam, help us out with row 2, column 2. Okay, 0 plus 6, that's 6, plus negative 35 is negative 29. And that is our product matrix. Any questions so far about the multiplication technique, process? All right, write your answer down. I'll give you about 30, 45 seconds and see if you can come up with the product for letter C. Okay, so our final product matrix should be 14, 16, 2, 28. Okay, and just give me some verification again. I've already seen just about everybody, but let me make sure. Who got it right? That is 100%, I think. Great. You guys are catching on really quickly. Okay, let's try this one. Chris, give me the dimensions of the blue matrix. 2 by 3. All right, and Matthew, what about the red matrix?
3 by 1.
So can these be multiplied together? They can. And Riley, the dimensions of the product matrix should be 2 by 1. A 2 by 1 matrix, 2 rows with 1 column. It's like a number over another number. So let's see if we can figure out what this product matrix is. Let me go to Jalen. Help me out with row 1, column 1 of the answer. Very good. And when you put all that together, what do you got? I'll help you out a little bit. 27. Good. All right, now let's work on row 2, column 1. So Carly, help me out. Very good. Let's add them up. 0 plus negative 45, and then plus 16, that should be negative 29. Any questions about Roman numeral 3D? All right, Matthew, give me the dimensions of the red matrix. 2 by 3. Kennedy, the blue matrix. Ooh. Can we do it? No, we can't. These middle numbers do not match. So if this were a homework problem, all you're going to do is say not possible or undefined and move on to the next problem. All right, just a couple more examples. John, the dimensions of the red or the left matrix. 1 by 2. Chris, the right matrix. Okay, Dalton, is this possible? Yeah. And the dimensions of the product matrix? 1 by 1, that's just a single number inside the brackets. It's a single number matrix. So I want you to take just maybe 30 seconds, maybe less, and come up with that product matrix. So raise your hand if you got negative 20. Very good. Very good. Any questions? All right, doing great. Let's try this one. I think this is our last one. Let's verify that it's possible. This is a 2 by 2. This is a 2 by 4. The inside numbers agree. So the outside numbers tell us what the product matrix should be. It's a 2 by 4. And I'm going to let you finish it, and we'll come back and we'll see who got it right. All right, so you can see our final product matrix here. And any last questions before we start? All right, you have the slide there that's got the homework assignment. These are on RenWeb, just like the previous two. They're not on Moodle yet, but I'll probably put them there. But you can at least go to RenWeb and find those just like you found the other homework assignments. Great job. Let me know if you need any help.